So before going to oxidize alcohol, we have three types of alcohols. Number one, this is carbon which is attached with OH when it's connected with two hydrogen atoms. So it's gonna be 1 degree alcohol, like it's a primary alcohol. And when we have like one hydrogen atom which is connected to the carbon having the OH ion, like the OH hydroxy functional group is a secondary alcohol. And in the same way, when we have no hydrogen atom, so it's going to be, I can say, tertiary alcohol. So we must know this. Whether you take R as a standard, like you have to look at the R and decide the type of alcohol, whether it's primary, secondary, or tertiary, or whether you can look at the hydrogen atom. If we have two hydrogen atom, it's going to be primary. And if we have one hydrogen atom, it's going to be secondary. And if there is no hydrogen, so it's going to be tertiary alcohol. So as we are going to oxidize alcohol, so we need some sort of oxidizing agent. In Oxford AQA specification, they told us that uh, acidified potassium dichromate is a suitable oxidizing agent. So we would be using K2Cr2O7, like potassium dichromate, as a as an oxidizing agent, K2Cr2O7. So it's going to be oxidizing agent. Oxidizing agent. It's going to be K2Cr2 and O7. But whenever we oxidize any alcohol in the presence of any of the alcohol, or you can say oxidizing agent, so we acidify this, or I can say acidified potassium dichromate. We say acidified potassium dichromate because acid is used as a catalyst. In an oxidation, acid is used as a catalyst. So,
Okay.
in short, we write Cr2O72 minus H plus. This is the, you can say, symbol for an oxidizing agent. In short, we can also write this one. In short, we can also write this one like O. O means oxygen, like it's a symbol for oxidizing agent. And since the oxidizing agent is K2Cr2O7. So, of course, it's orange. It's orange in color. And after oxidation, it will turn into green. After
Okay.
oxidation, it will turn into green. This would be an observation. As a result of oxidation, the oxidizing agent will be turning its color from orange to green. So let's take primary alcohol. That's going to be CCOH. It's ethanol. I'm taking ethanol and I'm oxidizing it in the presence of K2Cr2O7 and acidifying this. And I'm also heating this. Heat and distilled. Heat and distilled. Distilled means heat and distilled means once the product is formed, so I have separated the product. Once the product is formed, I have separated the product. So remember, the product of ethanol is going to be aldehyde first. First of all, it would be forming aldehyde like this. This is aldehyde, and this was primary alcohol. So why this is primary alcohol? Because the carbon which is connected with OH is having two hydrogen atoms. When it's having two hydrogen atoms, so it's going to be primary alcohol. So the product is aldehyde first. And let me explain distilled because they mentioned that you need to know when primary alcohol will be oxidizing into aldehyde and the condition is heat and distilled. This is, and the next thing is that when I'm not distilling it, like I'm only saying that I'm heating it, but under reflux, it's mean that I'm continuously heating it. I'm not separating the product. So then the final product would be carboxylic acid, not an aldehyde. So we must know distilled means heat to turn liquid into vapor, and then it's condensed back. It's condensed back in a separate container. It means that the product is heated and distilled. Let's say I have taken round bottom flask. I have attached a condenser like that. This is going to be the thermometer, and the same thing, water in, water out, like that. And this is the container, a separate container. In this, I have 1 degree alcohol and I'm heating it. The aldehyde is formed. The vapors of aldehydes are going into this condenser, and the condenser is turning that vapors into the liquid. So I'm collecting the liquid. It's going to be your aldehyde. It's going to be your aldehyde. So this is the first product. Whenever we take primary alcohol, so this would be the product. And then what if I'm getting the same reactant, but with the same oxidizing agent, but heat under reflux. Like I'm not using the condenser. I'm not using the condenser. So if I would not be using the condenser, when the vapors will be forming, when the vapors of aldehyde would be forming, so again the vapors will be going back to the container and I'm continuously heating the reaction mixture. So once the aldehyde is formed, the same product, once the aldehyde is formed, the same product, so in addition of continuous heating, I would be getting carboxylic acid. So in short, the product is carboxylic acid. In short, the product is carboxylic acid. So this is carboxylic.
All right.
In a one-step
So the primary
process,
alcohol is the primary alcohol is heated like with the uh chromium. Wait, what is Cr2O7 again?
dichromate, oxidizing agent.
Dichromate. Yeah, it's heated and what's reflux again?
Heated under reflux, like I'm not
What's
separating the product. Means that,
okay?
as I told you, heat and distilled means to separate out the product. In this case, aldehyde is formed, yes, but I'm not separating it. So aldehyde is getting further oxidized into
Carboxylic
carboxylic
acid.
acid. Exactly. When you will be separating the product, I mean to say, once the aldehyde is formed and you are going to separate it, so then aldehyde cannot be further oxidized because you have separated aldehyde from the reaction mixture. You have separated aldehyde from the oxidizing agent. You are not heating it. So aldehyde will remain aldehyde. It's not converting into the carboxylic acid, but now I'm not separating the aldehyde from the round bottom flask. Still I'm heating it. Still there is an oxidizing agent like dichromate. So you will see that the aldehyde would be converting into the carboxylic acid. Okay? Simple. So this is all about primary alcohol.
Okay.
This is all about primary alcohol.
Wait, so this is
And what
primary
I
alcohol.
have secondary alcohol.
So this primary alcohol being changed into um carboxylic acid, right? Like this is the.
Exactly.
And
Yeah.
what's the point of the first part then? Like, oh wait,
Because
like what's the
sometimes
difference
you
between heat under reflux and heat and distill?
I told you heat and distilled, okay? What do you mean by heat under reflux? Heat under reflux means that let me write it down. Heat under reflux.
Okay.
Heat chemical mixture constantly without losing solvent or reagent.
Sir,
This
I
is
think
called heat under reflux.
yeah, that makes
Mhm.
sense. But I mean to ask, like, why don't you just do heat under reflex and then aldehyde instead of like heat and distill it, like heat and distill it? Like, what's the difference? And
No, the
because
thing is,
I'll give you aldehyde, right?
yes, the thing is, sometime you will see in the product side, aldehyde is formed and the reactant is primary alcohol. Then he would be
Mhm.
asking to write down the condition, number one. And sometime in exam, you will see that the product is carboxylic acid, and on the arrow, you will be missing everything. So then you are supposed to
Oh,
write what is supposed to be the condition if the product is carboxylic acid, and what is supposed to be the product if the like what is supposed to be the condition if the
if
product
it,
is aldehyde.
got it. Okay.
Yeah, so that's why I'm telling you in both ways. So we
Okay.
need to know both things. Yeah.
So one would give
All
you
the
aldehyde
things.
and one would give you carboxylic acid.
Exactly. And the reactant is same, that is primary alcohol. Okay. Yes. And also, then we have secondary alcohol.
Okay.
For the secondary alcohol, of course, the oxidizing agent is the same. That is K2Cr2O7. And now the alcohol is this one, propane 2 all. Everything is the same, but you will see the product that is
Ketone.
what? Ketone. Degree alcohol, and the ketone is formed. So in secondary alcohol, there is no such concept of heat under reflux and heat and distilled, because it's a one-way reaction. Directly ketone is formed. In the previous reaction, carboxylic acid was your final product, but the carboxylic acid is formed in a two-way process. Number one, first aldehyde is formed, and then afterwards we have oxidized aldehyde into the carboxylic acid. But right now, when we have a secondary alcohol, and when secondary alcohol is getting oxidized into the ketone, so we have only one step. So we will be only doing heat under reflux directly. Okay, heat under reflux, heat under reflux.
Okay.
Yes. And also, um, let's say I'm going to write in this term. I'm getting the same reactant, but it's oxidizing agent, or also I can do like that. So the product is this, and water is formed. This can also be the chemical reaction in terms of this one, because you would be asking, use the symbol O for oxidizing agent or oxidant. The same thing, of course, we have to see the product. So in short, from the secondary alcohol, the ketone is formed. From the secondary alcohol, the ketone is formed. And what if I'm having tertiary alcohol? What alcohol? Tertiary alcohols, they cannot be oxidized further. Let's say this is the formula for tertiary alcohols, CH3, then CH3, then CH3, and again I am using the same oxidizing agent, dichromate, in presence of acid, and I'm going to heat it. I'm going to provide strong heat to this tertiary alcohol. As a result of this, you will see that no reaction, no reaction. Why? It cannot be oxidized further. Since we know that oxidation is the loss of hydrogen. Oxidation is the loss of hydrogen. Let me tell you, when we were using primary alcohol, so this hydrogen and this hydrogen is lost because it's being oxidized. The loss of hydrogen, you will see in the product side, there is no two hydrogen atoms on the second carbon. It has only C double bond OH. So it's the loss of hydrogen. We have an hydrogen, so it can lose its hydrogen. But what if, let's say in the secondary alcohol, this is your hydrogen, free hydrogen. So the hydrogen is lost, so the ketone is formed. But what if I have such alcohol in which there is no free hydrogen? I'm not talking about CH3. I'm not talking about CH2. I'm talking about only H. I'm talking about only H. So free hydrogen. So in tertiary alcohol, there is no free hydrogen. So this is why it cannot be oxidized. And also, This is partial positive, this is partial negative. It's having tertiary carbocation, as we discussed. Tertiary carbocations are more stable. Tertiary carbocations are more stable. So that's why it cannot be further oxidized. So let me summarize it. When we have primary alcohol, when we have primary alcohol, so they can be oxidized into aldehyde. And but this is what heat and distilled in
Okay.
the presence of potassium dichromate, and also I'm going to heat it but under reflux. So the product is carboxylic acid. And also when we have secondary alcohol, okay, so secondary oxidize into ketone. This is secondary alcohol to ketone directly. And also tertiary alcohol. So no product. For the tertiary alcohol, no product. This is all about oxidation of alcohols. When we have primary, when we have secondary, and when we have tertiary.
So there's no, like, we cannot make a carboxylic acid or something with the secondary alcohol, right?
No, no, no. Secondary alcohol gives us ketone directly, not carboxylic. If you are getting carboxylic acid, so you must have a primary alcohol. Okay.
Right, right. And tertiary
Yes.
won't give you any. Okay, got it.
Yeah, exactly. And also, how can we differentiate between aldehyde and ketone? Let's say whether aldehyde is formed and whether the ketone is formed. Of course, after looking at the products, of course, after looking at the product, we can also identify the reactant side. Let's say in the product side, if I'm getting an aldehyde, so I can predict in the reactant side there would be primary alcohol. That's why I'm getting. And after getting ketone, I can get an idea. Okay, if I'm getting ketone, so in the reactant side, I must have a secondary alcohol. So first of all, you have to identify whether there is an aldehyde or ketone. So in this way, I have.
Sorry, your
How
voice,
can I
uh,
confirm
uh,
it?
your voice is cutting out a bit.
Now, now, okay.
Now,
Hmm?
now it's a bit better, yeah.
Okay. So I was saying in a ketone, once the ketone is produced, so how can I confirm it? Confirm test. Confirm test for ketone.
Sorry, your voice is still cutting out. I don't know why. My internet's